Assalamu alaikum. Good morning, everyone. Today we will continue the lesson that we already started yesterday, lesson 11.5, angle relationships in circles. Again, the main objectives here to find the measure of angles formed by lines that intersect circles and use angle measures to solve problems. Okay, now yesterday, what did we do? We knew if the theorem that talks about if the secant and the tangent intersect on the circle on the point of tangency. So what is the relation between the angle and the arc? And also if the two secants intersect inside the circle, then what is the measure of the angle related to the arcs inside the circle? Now the third idea today is what if we have two secants, two tangents, or secant and tangents, but the difference here is that they all intersect outside the circle. As you can see in the first case here, we have a tangent and a secant, like the first theorem, if you remember. But in the first theorem, the secant and the tangent, they intersect exactly on the circle, on the point of tangency. But here they intersect outside. C is outside the circle. The second case is also if we have two tangents and they also intersect outside the circle on F. Here, outside. What if we have two secants? This is a secant, this is a secant, like the second theorem. We had two secants or two chords. They intersect inside the circle, but here, again, they intersect outside the circle here at L. Okay, what is the case here? If any two tangent and secant, two tangents or two secants intersect in the exterior of a circle, outside the circle, then the measure of the angle formed is half the difference of the measures of its intercepted arcs. What does it mean? It means here in the second theorem, if you remember, that if they intersect inside the circle at a point which is interior of the circle, then what did we do? We added the front arc and the behind arc, then we divided the answer by 2. But here, what we will do is to subtract the big arc minus the small arc, then divide the answer by 2. Again, we will subtract this arc AD, measure of arc AD, minus measure of arc BD, then divide the answer by 2. Or we can say that measure of angle 1, which is outside the circle, the intersection is outside. Measure of angle 1 is equal to half measure of arc AD minus measure of arc BD. In the second case also, here the intersection is outside. Measure of angle 2 outside, measure of angle F here is equal to the big arc, which is in front of angle F, a measure of arc EHG minus measure of arc EG. Look here, we can't say measure of arc EG, because if we said arc EG, then we don't know which arc we want. EG this one, this path here, or EG this one. So we have to mention another point here in order to distinguish between them. So measure of arc EHG minus measure of arc EG, and divide the answer by 2. Okay, the third case here, two secants intersect outside in angle 3, outside. What is the measure of this angle 3? We will subtract measure of this arc minus measure of this arc and divide the answer by 2, or subtract this minus that and take half of the answer. This is our last theorem in this lesson. Okay. Example on this theorem. Find the value of x in these two figures. The value of x here, what is the x here? It is the measure, the angle measure here outside, the angle measure there outside. Look, what if we want to look here, the E, the intersection of the two secants is at exterior point, which is E, of the circle. Now this here, what do we have to do? Simply, we have to subtract the arc, the big arc, minus the small arc, then divide the answer by 2. Also in here, what do we have to do? This is the plan. This is the application of the theorem. The arc, measure of the arc AD minus measure of arc BD, then divide the answer by 2. Let's see the solution. So half the subtraction of, or half the difference between the two arcs, half 78 minus 7, half 80, which is 40. And B here, half of measure of AD, arc AD minus measure of arc BD, then substitute the values 200 minus 40 74 to get 63 at the end of the solution. Okay. Now check it out. 3 for example 3. Find the value of x again here. Okay, here it is now indirect question. Now we know the angle measure here. The exterior angle, we know the exterior angle, and we know the big arc, this one. So we want to know the measure of this small arc, Km. How to find it? In the first look, what we will say? We will say that this 25 comes from what? Comes from the difference of 83 and x degrees, and take half of the answer. Okay, so write the equation. Measure of angle L is equal to half measure of arc Jn minus measure of arc Km. Substitute the values. Measure of angle L is known here, it is 25, half of 83 minus 83 minus the small arc, which we don't know. Now, here, what did we do? We moved the 2 to the other side by multiplication. Here, half of this arc. Now get rid of this half by moving the 2 there by multiplication. So if we move the 2 there, multiply by 25, we get 50. Now 50 is equal to 83 minus x. Solve the equation to get x is equal to 33 degrees. We move the x in the left side and 50 to the right side to get 33 degrees for this x. Now if we want to be sure if our answer is correct, so we will subtract 83 minus 33, which is 50, then divide the answer by 2 to get 25. This is how we can check the answer. Okay, now as an application for this theorem, 2 of the 6 muscles that control eye movement are attached to the eyeball and intersect behind the eye. If measure of arc AEB is equal to 225, what is the measure of this exterior angle ACB? Now this is the last case, the theorem number 3. Here, what do we have to do? As we know that we must find now here the measure of of angle ACB, measure of angle C is equal to the big arc, measure of the big arc, measure of angle AEB minus measure of arc AB. Okay, now we don't know here what is the measure of arc AB, but we know that ABE is a full circle. This all is 360. We know the measure of AEB, which is 225. So how much is the measure of this one? We will subtract this from 360. Let's start the solution. Now measure of angle ACB is equal to half of the big arc minus the small arc. Okay, substitute the values that we have here. Half times 225. From where is the 135? As we said that AEB and AB will form a full circle. Full circle means 360 degrees. So this is 225. Subtract it from 360 to get this 135. Now subtract, then find the half, which is 45 degrees. This is the angle measure, the exterior angle measure. Okay, thus finally, this is the summary of the lesson. We have, as we said, three relationships in circle, angle relationships in circle. Now, if the angle is on the circle, or if the angle inside the circle, or if the angle outside the circle, exterior point of the circle. If it is on the circle, then simply the measure of this angle is half of the arc. This we took it in the previous lesson, not in this lesson. This is an inscribed angle. We said that the measure of the inscribed angle is equal to half of the intercepted arc. So this measure of angle 1 is equal to half of 120, which is 60, or if we have these here, we have two secants. Now, if you have a tangent and a secant, then measure of this angle, which is between the tangent and the secant, is equal to half of 200, which is 100. The second case here, if it is inside the circle, if the angle is inside the circle. If it is inside the circle, then simply we will add the front arc plus the behind arc, then divide the answer by 2. So 68 plus 44 divided by 2, which is equal to 65. Last case, if they intersect outside the circle, the exterior angle, this exterior angle is equal to the difference between the two arcs, intercepted arcs. 202 minus 78, we get then the answer divided by 2 to get 62 degrees. Here, if it is a tangent and a secant. If two secants, no difference, again, we will subtract 125 minus 140, minus 45, then divide the answer by 2. That's all for this lesson. Hope it is clear. Thank you for listening, concentrating, and focusing. If you have any doubt, please tell me. Bye-bye.